just going to look at a new type of question that came in with dealing with simulations. You can stop the recording and have a read of the situation, but it's about the fineness of wool, and it's based on sheep, Awasi sheep in fact. The assumption is that their fineness is uniform, but they've taken a sample. The sample is in blue. The sample isn't uniform exactly because a uniform sample would be the same all the way across. So the question really is, allowing for randomization, can we live with that amount of difference? That's what it comes down to. So to get a bit of background, I've approached it that way. First of all, there's a picture of a sheep. That's the right breed. They're quite a strong wool sheep. Now, I've done a simulation, and in the question there's 49 sheep. And so I've got 49 cells here now. I'm going random between 1 and 4 because in the question they're put into 4 intervals and it's assumed they're uniform. So there's likely chance that they're between 30 and 40 and 50 and 60 and so on. So I've simulated 4 groups. The idea is to see the range. If there's 4 equally likely out of groups and 49 instances, we expect 12.25 of each. And so here's my first selection, and if I click on it, I've got an 18, I've got an 11, I've got a 12, and I've got an 8. If I run it again, I just delete that and put the 1 back in. This time, if I click on there, I've got a 14, I've got a 15, I've got a 13, and down the bottom end I've got a 7. I run it again, and now I've got a 9 by the look of it, a 9, an 11, a 12, and at the top end I've got a 17. So I'll do one more. What I'm doing, and this is important to keep in mind, is I'm running one trial of the simulation. In the question, they've pictured 1,000 of them. I'll do one more. I take that out, put that back in. There's another trial. This time I've got a 10, it looks like a couple of 14s, and an 11. And so each time I'm getting a different number. And the assumption here, though, is this is a uniform assumption because there's just random between 1 and 4, so they've got equally likely opportunity, and this is my 1s, this is my 2s, this is my 3s, and this is my 4s. So if I keep doing that and recorded those individual ones, it would look like these brown lines here. They've run it 1,000 times, that's why there's some that are lighter and some that are darker, because there's a whole lot of overlap. So the question is what we see with the blue, which is clearly not exactly uniform, but it's only one sample. Is it close enough? And the answer given to us by the simulation is yes, because each of these values, that one, even this one, which is the lowest, and this one, are all safely within the band that is created by the randomized simulations. Those simulations are all done assuming that the 4 intervals are equally likely, much like the examples on my spreadsheet. They're not just in a nice tidy straight line with 12.25 of each. They are varied and different, but what we see is this, but the assumption there is they're equally likely, therefore uniform, and what we see in blue that's recorded is within the scope of that. So if we go to the mark scheme, this is how they've written. A simulation shows evidence that the proposed uniform model is appropriate, okay, and then they give the context, always add the context, so it's to model that wool fibre. The uniform, so we do a little bit of an assumption here, they're equally likely. Each wool fibre class in the observed data appears in the grey cloud of variation, which is kind of almost a new bit of language for me as a teacher. So we're saying, so they've run the simulation, the grey cloud of variation spans or gives a band of what is possible within those assumptions, and therefore the model is appropriate. This is based on the 2023 paper, and it was part of question 2, I think. No, it's the latter part of question 1. There is a similar question in 2024, so it seems to be a style of question that is coming up now. So hopefully that's some help. So when we see that, just remember it's a whole lot of individual randomized run through and 1,000 of them, recorded on top of each other to give us an idea through randomization, through a simulation of what is possible even when each of those 4 classes are considered to be equally likely. Okay, thank you.